Good afternoon, all. So this is week 11 microelectronics device to circuit problem solving session. I'm Arpita Biswas, a PhD scholar in electrical engineering department from IIT Jodhpur. And this is more details about me. And this class session is every Tuesday, 7 to 9 p.m. So let's start the session. So this is question 1. So identify the following op-amp circuit topology. So first one is the summing integrator circuit. The second option is the differentiator circuit. Third one is the multiplier circuit. And the fourth one is the subtraction circuit. So take your time and try to give the right answer. You can unmute yourself. Am I audible? Hello. Okay. Okay. So the right option is the summing integrated circuit. This is the question number 2. If a sine waveform is applied at the input V input of the following circuit, then predict the waveform at the output of the circuit. So see the circuit carefully and try to give the right answer. First option is the sine waveform signal. The second option is the cosine waveform signal. The third option is the triangular waveform signal, and the fourth one is the square waveform signal. So if a sine waveform is applied at the input voltage of the following circuit, then predict the waveform at the output of the circuit. Okay. Yes, the right option is the cosine waveform of the cosine waveform signal. Okay. So next move over the question number 3. Implement the logic function of the given CMOS design. Please assume that a CMOS inverter is connected at the output node V output and the final output is V output. Sorry, this is on the V0 and the final output is V output. So see the circuit carefully. And the first option is V output equal to A into B plus C into D plus E. And the second option is V output equal to A into B plus C into D into E. And the third option is V output equal to A into D plus A into E plus D into C plus B. And the fourth option is none of the above. So try to solve this question. Implement the logic function of the given CMOS design. And please assume that a CMOS inverter is connected at the output node V0 and the final output is V output. So try to find out the answer. Implement the logic function of the given CMOS design and please assume that a CMOS inverter is connected at the output node V0 and the final output is V output. So see the connection of A, B and C and the D. D or E also. See from here, this A and B, it is in series connection. How it will you will write it? Series connection and connection A into B and it will parallel with C which is series with this D and E which is parallel. So D and E how you will write D plus E it is parallel okay. So D plus E and it is series with C. So multiply with C and it is also parallel with that one. So parallel it is in plus. Okay. But here also see if only V output you have to find out then the whole bar is coming. Okay. But what tell here implement the logic function of the CMOS design. Please assume the CMOS inverter is connected at the output node. So output will come out total. Okay. Total bar but here it is mentioned that a CMOS inverter is connected at the output. So inverter is connected, so it will come out like A into B plus C into D plus E. It is clear because A series with B, which is written by like this A into B. Okay, and it will parallel with that portion. Okay, it means C, which is series with D and E parallel. So D and E parallel means D plus E, and it is series with C, which is total parallel with the A plus B, which is series. Okay, and the output is coming out the whole bar, but here it is mentioned that a CMOS inverter is connected at the output net V0. So if it is inverter is connected, then the bar will cancel out, and then it will come one A into B plus C into D plus C. So which option is the right answer? The first one, right? Now this is the question number 4. The Boolean function y equal to a into b plus c into d is to be realized using only two input NAND gate. The minimum number of gate required is first option is 2, the second option is 3, the third option is 4, and the fourth option is 5. So try to find out the right answer. So you have to make that one y equal to a into b plus C into D by using this two input NAND gate. So the number of gates required is how much? How many? Okay. So the right answer is option D. So how we will define it? Like NAND gate. This is two input NAND gate. So if it is A and that one is B, what is the output here? A into B bar. And that one C and D. So what is the output here? CD bar. And it will connect it with another NAND gate. So what will coming out here? A into B bar into C into D bar in whole bar. Okay. So if you simplify it, you will get A into B double bar plus C into D double bar. It means A into A into B plus C into D. So this is the right answer. Okay. So you need 1, 2, and 3. So total 3 gate. Okay. So this is the question number 5. The number of Boolean function that can be generated by n variable is equal to. So the option are there A, B, C, and D. So try to find out the right option. So what is the right answer here? T. And for any variable A can have two values. Okay, either 0 or either 1. Okay, so for in variable, there are 2 to the power n entries are there in the truth table. Okay, and each output of any particular row in the truth table can be 0 or odd on. So hence we have 2 to the power 2 to the power n different Boolean functions with n variable. Okay, so if n equal to 2, so Boolean function will coming out 2 to the power 2 to the power n. It means 2 to the power 2 to the power 2 to the power 16. Sorry, 4. It means it will come 2 into 2 into 2 into 2. So total 16. Okay. So what is the right answer here? The first one, but it will come 2 to the power 2 to the power n. Okay. The right answer is the first option. That one. Okay. So next move over the question number 6. So what is the functionality of the circuit given below? Note that VDD is the supply voltage, A and B are the inputs, and F represent the output of the given circuit. So carefully see the circuit and try to find out the right answer. So first option is the SRAM cell. The second option is the XNOR. The third option is the latch, and the fourth option is the none of the above. So take your time. There is no hurry, but at least try. So what is the right answer? What is the functionality of the circuit given below? Note that VDD is the supply voltage, A and B are the inputs, and F represent the output of the given circuit. What is the right answer? So let's simplify the circuit. See. So this is the one, this is two, this is three transistor, and this is four. So now can you calculate if after simplifying this, there is a B is coming in this four PMOS. Then A is in the gate connection of this P type MOSFET. Then there also A is connected, and here in the gate the B is connected, and in the transistor 2 A is connected to the gate, and the source is connected to the that one, this one, this B. So now can you calculate? So take your time and at least try. So in the first case, take both A and B 0. Then tell me the which MOSFET is on condition and which one is off condition. So if A is 0 and B is 0, in that case, both NMOS and both NMOS 1 and NMOS 2 are off condition, right? NMOS 1 and NMOS 2 off, and PMOS 3 and 4, it is in on condition. So what will be the output? So output will come out 1, right? So here, if you are taking the truth table, right here A, B, and here is the output. Okay. So you're taking A 0, B 0, output you are getting 1. Okay. And next we are going for the second case. So what will happen in the second case? Now, second and third, we can second and third. Okay. A equal to 0 and B equal to 1. Okay. And or A equal to 1 and B equal to 0. So what happened in that case? In both cases, either NMOS is on and one of the PMOS is off. Okay. So what will be the output? Output will be 0. So if it is 0, 1 or 1, 0, the output will come out 0. Okay. Now we are going for the case 4. So, sir, are you getting the point? Or if you have any doubt, you can ask me. If you are not understanding anything, then you can unmute yourself. Okay. So let's take the fourth condition, case 4. So in that case, both NMOS, it's mean the 1-1 condition, right? Both NMOS are on condition. So NMOS will pass and PMOS off. So NMOS will pass logic high from input A and B, right? So what will be the output? Output will be the 1. Now tell me in which gate this truth table is coming. Please unmute yourself, Gosa, and tell me for which gate we are getting this truth table for a is RAM cell for XNOR, latch, or none of the above. At least tell me for which gate this type of truth table is coming. Then you can find out the answer easily. Please you can unmute yourself. Okay, take your time, but at least try. Where 0 A 0 0 output is coming out 1. Then 0 1 it is coming out 0. Then 1 0 it is coming out 0. Then 1 1 it is coming out 1. For which gate this type of truth table is coming? So for X nor, A X nor B. How you can write it A into B plus A bar into B bar. So in that case, what is the truth table value? A, B, and this X nor. So how it will come? A equal to 0 and B equal to 0. Then it will come 0, 0, 1, 1. It's mean 1, right? Then 0, 1, 0, 1. It will come 0. 1, 0. It will come 0. If it is 1, 1, then it will come 1. So it will, this truth table is matching with the XNOR. Okay. So the right answer is the XNOR. So next move toward the question number 7. The given op-amp circuit configuration represents a. So carefully see the op-amp circuit and try to find out the right answer. The first option is the low pass filter. The second option is the high pass filter. The third option is the band pass filter, and the fourth option is the none of the above. So the given op-amp circuit configuration represents a. The first option is low pass filter. The second option is high pass filter. Third option is the band pass filter, and fourth option is none of the above. So what is the right answer? Take your time, but at least try. So what is the right answer? See, take two condition. Okay. First, at omega equal to 0 or low frequency. So at low frequency, a capacitor Gausa, please unmute yourself and tell me at low frequency how this capacitor behave. It will open circuit or short circuit. Please unmute yourself. Gausa. So at low frequency, a capacitor behave like open circuit. So how we will find out the V output by V input is minus R2 by R1, right? Because this will open circuit. And here is only R2 present and that one the R1. So you can write down here the V output by V input is R2 by R1. So now take another condition, the case 2. This is the case 1 and this is case 2. So at W equal to infinity, what? High frequency. So what happened in the high frequency? A capacitor behave like open circuit or short circuit? Tell me. It will short circuit. Short circuit. Okay. So in that case, V output by V input. If it is short, it behave like a short circuit. So no current is flowing from this resistance because from this portion it will flowing. So what happened in that case? The R2 is tends to 0. So in that case, V output by V input is equal to minus 0 by R1, right? So V output by V input equal to 0. So in which filter condition it is behave like in low frequency? See, you are getting the V output by V input value. But in high frequency, it is 0. It means it is a low pass filter. Okay, is it clear? So next question, question number 8. If the op amp in the figure has an input offset voltage of 5 millivolts and an open loop voltage gain is 10,000, then determine the value of V output. So carefully see the circuit and try to find out the answer. So first option is 0 volt. The second option is plus minus 15 volt. The option C is plus minus 50 volt. Option D is none of the above. So what is the right answer? Gosa, please unmute yourself and try to give the answer. Kausa, you can unmute yourself when you are giving the answer now. Because in between lecture it is difficult. So you can unmute yourself. We can directly give the answer. Okay. So try to find out the answer.
Plus or minus 15 volts.
Oh, plus and minus.
15, 1 5.
Oh, okay. Can you a little bit explain how you have calculated? Yes, the answer is right. But how you have calculated? Can you please little bit explain?
When you are not applying any input, the output voltage will be equal to plus or minus V saturation or plus VCC minus VE.
Okay. Okay. So see here the input offset voltage is given, which is 5 millivolt, right? And the open loop gain also given, which is 10 to the power 4. So output voltage can be 5 millivolt into 10 to the power 4, which is around 50 volt. But it is exceed this 15 volt. Here the V saturation, I think, is given plus minus 15. So this voltage is 50, which is greater than this plus minus 5, 15 volt. That's why this is not the correct answer. Okay. So that's why the answer is plus minus 15. But if it is less than the this in between this plus minus 15, then we can take that voltage. But here the voltage is going the exceed the plus minus V saturation, which is plus minus 15. That's why the right answer is plus minus 15 volt. Okay, and you have to write the output voltage cannot go beyond plus minus 15 volt. Okay. So next move towards the question number 9. So name the transistor logic in which the logic input are applied in gate as well as the source and the drain. So first option is the fast transistor logic. The second option is the CMOS logic. The third option is the transistor logic, and the last option is the none of the above. What is the right answer?
Pass transistor logic.
Yes, the right answer is the fast transistor logic. So this is the question number 10. The dynamic power dissipation in a CMOS logic circuit is given by P equal to alpha CL VDD whole square into F. What is the alpha in the relationship? First option is it is called the alpha particles. Second option is it is called the switching activity. Third option is it is called the operating frequency. And the fourth option is none of the above. What is the right answer?
Switching activity.
Yes, the right answer is it is called switching activity. Good. So next question number 11. An integrator contains a 100 kilo ohm and 1 microfarad capacitor. If the voltage applied to the integrator input is 1 voltage, then what is the voltage present at the integrator output? after 1 second. So first option is 1 volt, second option is 5 volt, third option is 2 volt, and fourth option is 10 volt. So take your time, there is no hurry, but at least try. In integrator contain 100 kilo ohm resistance and 1 microfarad capacitor. If the voltage applied to the integrator input, so input voltage is given, the input is given, which is 1 volt. The resistance also given, which is 100 kilo ohm, and the capacitor value is given, which is 1 microfarad. So now tell me what is the value of V output after 1 second, and it is an integrator circuit. Try. So let's draw the circuit here.
10 volts.
Yes. So the V output is grounded, and here the V input is given. R value is here, and here C. So how to can you little bit explain how you have calculated?
Uh, for integrator, the formula for voltage output voltage equal to V naught equal to 1 by RC integral of input signal.
Yes, actually there is a minus signal, a minus sign is there. You can see carefully.
1 by
Minus
RC
1 by RC, integration of 0 to T into V input
V.
dt. Yes, good. So just put the value 10 kilo ohm. Sorry, it is 100 kilo ohm. And the value of C is 1 microfarad, 10 to the power minus 6. And the time is going to after 1 second, 0 to 1. So the input is also given, which is 1 volt, then the dt. So if you, it is minus 10 volt, it is coming out. So this is the V output. So here the sign actually, they're taking the magnitude. That's why the 10 volt. Yes. So this is the question number 12. So this circuit represents the subtractor, integrator, adder, or differentiator. I think this is a very basic question, and in the previous question you can also give the right answer. So this circuit represents subtractor, integrator, adder, or differentiator.
Integrator.
Yes. So this is the question number 13. The value of the output voltage of an integrator when the input is a step voltage, which is 0 less than equal to T, then less than equal to 2. Um, and R1 and CF is given 3 seconds, and the V input is given 6 volt. So you have to find out the output voltage. V output you have to find out, and what try to find out the what is the right answer. First option is minus 6, second minus 8, third minus 10, and fourth minus 4.
Minus 4 volts.
Okay. So just directly put the formula here, minus 1 by RC into integration of T, then V input into dt. Minus 1 by RC, so it is given 3, is 0 to t, it means 0 to 2, 6 into dt, minus 1 by 3 into 6, and dt is 2, minus 4 volt. So the integrating transfer function has the value of, the first option is j omega CR, second option is minus of j omega CR, the third option is 1 by j omega CR, and the fourth option is minus 1 by j omega CR. So what is the right answer?
D option minus 1 by j
1
omega
by
CR.
j omega CR, yes. So this is the question number 15. So uh, there's given the op-amp, the CMRR is given, which is 10 to the power 5. Differential gain is also given. What is the common mode gain of the op-amp? So you have to find out the common mode gain. So first option is 10 to the power 10. The option B is 2 into 10 to the power 5. Option C is 10 to the power 5, and option D is 1. So try to find out the,
Option D 1.
yes, option D is the right answer. How we have find out? What is the formula?
CMRR equal to
CMRR,
AD by A formula.
yes, AD by ACM, and it is infinitely for ideal op-amp, infinity for the ideal op-amp. And how to find out? The CMRR is given here, and a CMRR is equal to 10 to the power 5 by ACM. So ACM is equal to 1, because both are the same. The gain is also same. It is 10 to the power 5. The right option is option D. This is the question number 16. An amplifier circuit has a voltage gain 500. If the output voltage is 5 volt, then the input voltage is, first option is 1 by 2500. Second option is 2500. Third option is 100 millivolt. And fourth option is 10 millivolt. This is the MCQ, 1 marks MCQ question. An amplifier circuit has a voltage gain 500. If the output voltage is 5 volt, then the input voltage is,
Option D 10 millivolts.
yes. Just directly put the equation the output by V input. And here AV is given 500. And what is the value of V output? 5 volt. And you have to find out the V in. So what is the value of V in here? 5 by 500. It is coming around 10 millivolts. Okay. So this is the question number 17. Which of the following logic expression represent the logic diagram shown? So see the logic diagram carefully. So first option is A into B bar plus A bar into B. The second option is A into B whole bar, then the A plus B. Then third option is A into B whole bar into A bar into B bar. And the third option for last option is A bar into B bar plus A into B. So please try to find out the answer. I'm coming back in 1 minute. So what is the right answer?
Option D.
Okay. Can you little bit explain? Hello. See, here it is going from a NOT gate. Okay. So here you are getting A bar. Here B is going from this NOT gate. So here output is B bar. Then it is going passing from the AND gate. A bar into B bar. Right? And here also A and B directly passing from this. So A into B. Right? Then it is passing from the OR gate. So OR gate is A plus B, then plus A bar into B bar. Yes. So this is the X, X value, that one. So this is the question number 18. How many AND gates are required to realize the Y equal to CD plus EF plus G? So first option is 4, the second option is 5, the option C is 3, and option D is 2. What is the right answer? How many AND gates are required to realize the Y equal to C into D plus E into F plus G? So what is the right answer? Hello, am I audible? Hello, am I audible?
Audible, madam.
Okay, okay. Please try to find out the answer. Tell me how to represent the AND gate. If it is A and B, then what will be the output of a AND gate? A into B, right? So how can how you can so here C into D. So C into D we can write design by it. C into D. So here C into D coming out and E into F. So we can also represent it a AND gate E into F, right? E into F. And there is a only G is present and there is a OR gate. Plus means the OR gate. Okay. So C into D OR gate with this E into F and which is OR gate with the G. So the output of EF and CD it is OR gate with it and it is also OR gate with G because the output will come C into D plus E into F. If it is three input OR gate, then directly you can connect the G. But we are now taking two input, okay? And if you take the OR gate here, so what will be the output? Here G is connected. So OR gate means the plus sign will come out. C into D into E into F plus G. So it is the final output. Okay. So how many AND gate is required here? One and two. Okay. So the right option is option D. Is it clear?
Yes,
Now,
ma'am.
oh, so this is the question number 19. Find out the value of F. So see the circuit carefully. Here C, B, C, and D is connected. It is the NMOS, and this is the opposite connection is here. Like D is in the series. Here D is parallel with that one. So here A, B, C is a parallel condition. It is NMOS. So what will be the value of the F? Take your time. There is no hurry, but at least try. I think two more questions are there. Only today's class only one student. So this type of circuit you have to find out from the below how the connection it is. The whatever it is coming out from this circuit, now the total just bar, it will the value of F. Something is coming out from this connection and the whole bar is the value of F. And see the connection.
A plus B plus C into D.
Yes. And then whole bar, right?
Ah,
Because
yes.
A is parallel with B, which is parallel with C. So it will connect A plus B plus C, and this whole thing is series with the B, D. So it is D. And you can see the upper side also the same things. Now that's why the whole bar is coming. So this is the right answer. If equal to A plus B plus C into D and then whole bar. So this is the question number 20. An op amp has a finite open loop voltage gain of 100. and its input offset voltage VIOS is plus 5 millivolt. Is modeled as shown in the circuit below. The amplifier is ideal in all other respects. So V input is 25 millivolt. So you have to find out the voltage in millivolt, the output voltage in millivolt. So try to find out the answer. See what is given here. Yes, Pradeep. See this question carefully. An op-amp has a finite open loop voltage gain of 100. Okay. So its input offset voltage VIOS is plus 5 millivolt. Is modeled as shown in the circuit below, and the amplifier is ideal in all the other respects. So V input is 25 millivolt is also given. So you have to find out the output voltage in millivolt. And in practical purpose, you have to find out. Take your time. The formula you have to
480
use to,
millivolts.
yes, 4.
480.
No, it is not 480, but it is close to 413. And the practical value, tell me what is the practical value of V output by V input for an op amp where the input is given is the plus, is the non-inverting, right? Right? So in that case, what is the value of V output by V input for the practical purpose? The voltage gain.
As it is connected to non-inverting input 1 plus RF by R1.
Mhm. Yes. Uh, this formula you have to use 1 plus Rf by R1 by 1 plus 1 plus Rf by R1 by AOM. This formula for the practical purpose, no, you have to use that one. 1 plus Rf by R1 because if it is a ideal condition, in that case, you can use the V output by V input is equal to 1 plus Rf by R1 if it is non-inverting. But for the practical purpose, you have to use that one. 1 plus Rf by R1 by 1 plus 1 plus Rf by R1 by AOL. This is the open loop gain. Okay. Now you have to find out. Now you can calculate the what is the value of V output. Tell me. Here see. RF is the feedback register. You know that register. R1 is the input and AOL is the open loop gain. And R1 value is given. It is 1 kilo ohm. The RF is 15 kilo ohm, right? And the V, now you have to see what is the value of V in. Total V in is this V input and that one. And that VOI is. And V input is 25 millivolt. So you can directly write here 25 millivolt plus 5 millivolt. Yes, 5 millivolt. So total V input is 30 millivolt. So just put this 30 millivolt here in this equation. So V output is equal to 1 plus Rf by R1. So Rf value is 15 by 1. It's when 1 plus 15. Then 1 plus 1 by Rf by R1. This is also coming 16 by AOL. This is the open loop gain. And what is the value of open loop gain is 100. So this is the 100. And this is multiplied with the 30 millivolt. Okay. So it is the value of V output 16 by 1 plus 16 by 100 into 30 millivolt. Now tell me after calculation how much what is the value of V output?
413
Yes,
millivolts.
413.79 millivolts. Yes. So this is the value of only the difference is here. For the practical purpose, you have to use this formula. Okay. And for ideal case, you just have to find just put the equation of V output by V input, and it is for non-inverting, so 1 plus Rf by Rin. But here additional is 1 plus Rf by Rin by 1 plus Rf by Rin by AOL. Okay, that one. So next move at the last question. Here is also the inverting op-amp shown in the figure has an open loop gain of 100. So open loop gain is given here. The closed loop gain is V output by V input. You have to find out. So here the R R1 is given, R2 is also given the feedback resistance, and the open loop gain is also given. You have to find out the closed loop gain, and it is inverting op amp. So try to find out the answer.
minus 10.
How you have calculated? Can you please explain? The same formula, if you are applying now for the ideal purpose. Here you can see the open loop gain is also given. For the ideal purpose, if it is non-inverting, so in that case you can use V output by V input is minus RF by Rin. But here you can see in that question, the open loop gain is also given. So here you can assume that it is not the ideal. So you have to find out from the previous, from the practical, where the open loop gain is used. So what is the formula there? Only one where you are using the 1 plus RF, the upper side, you have to just put the minus RF by RN like that. Okay,
Okay, ma'am.
if it is, just a minute, I'm showing. If only it is, if the open loop gain is not given, only you have to find out the V output by V input. In that case, the V output by V input is, if it is inverting now, then minus RF by RN. From this formula, you can find out. But here you can see the open loop is given. So in that case, how to find out? V output by V input is given. It is inverting. From the previous case, it is non-inverting. That's why 1 plus RA by RA. But here, minus RA by RA. And remaining same. Okay. But in the below portion, 1 plus RA by RN by open loop gain. Right? Now you have to find out from there the value of V output by V input. Not tell me what is the answer.
Minus 9.
Yes, the right answer is minus 9. So just put down the value. RF value is minus 10 by 1. Then it is 1 plus 1 plus 10 by 1 by 100. Okay. So what is the value of it? Here we can write down there. It is minus 10 by 1 plus 11 by 100. It is coming around minus 10 by 111 by 100. So it is minus 1000 by 111. And it is coming out minus 9.009 volt. So it is approximately minus 9 voltage. So the right option is option B. Okay, so today up to this, we will meet next Tuesday, 7 to 9 p.m. You can leave.